Welcome back to the Lazy Cosmos, where we explore the most mind-bending mysteries of our universe. Today, we're embarking on a journey that should be impossible, traveling at the speed of light itself. You've probably wondered what it would feel like to move at 299,792,458 meters per second, racing alongside photons across the cosmic void. Hollywood movies make it look spectacular, with stars stretching into lines and space warping around you. But the reality is far more terrifying and beautiful than any science fiction could imagine. What we're about to explore isn't just theoretical physics, it's a deep dive into why the universe has set this ultimate speed limit and what catastrophic consequences would unfold if we somehow managed to break it. Einstein's special relativity tells us that nothing with mass can reach light speed. But today, we're going to shatter that barrier and see what really happens when physics meets the impossible. You'll discover why time would stop, space would collapse, and reality itself would break down around you. This isn't just about speed. It's about the fundamental structure of existence and why nature protects us from experiencing the ultimate velocity. By the end of this video, you'll understand why the speed of light represents more than just a cosmic speed limit. It's the boundary between the possible and impossible, the barrier that keeps reality intact. So buckle up for a journey that will challenge everything you think you know about space, time, and the nature of our universe. Trust me, what you're about to learn will change how you see light forever. Let's break physics together and discover what lies beyond the ultimate speed limit. Let's begin our impossible journey by understanding exactly why traveling at the speed of light is fundamentally impossible for anything with mass, and why the universe has constructed this ultimate barrier. When Albert Einstein published his special theory of relativity in 1905, he didn't just revolutionize physics, he revealed a cosmic truth that defines the very fabric of reality itself. The speed of light in a vacuum, precisely 299,792,458 meters per second, isn't just another number in physics textbooks. It's the universe's ultimate speed limit, a boundary that protects the structure of space and time from complete collapse. To understand why this speed limit exists, we need to examine what happens when any object with mass tries to approach light speed. Imagine you're in a spacecraft that can somehow accelerate continuously, pushing closer and closer to this cosmic barrier. As your velocity increases, something remarkable and terrifying begins to happen to your mass. According to Einstein's equations, your mass doesn't stay constant as you speed up. Instead, it grows larger and larger, approaching infinity as you get closer to light speed. This isn't just theoretical mathematics. It's been confirmed countless times in particle accelerators around the world, where scientists routinely accelerate tiny particles to near light speeds and watch their mass increase exactly as Einstein predicted. But why does mass increase with velocity? The answer lies in the fundamental relationship between energy and matter that Einstein captured in his famous equation, E equals mc squared. As you accelerate, you're adding energy to your system. That energy has to go somewhere, and according to relativity, it manifests as increased mass. The faster you go, the more energy you add, and the more massive you become. This creates a vicious cycle that makes reaching light speed impossible. The more massive you become, the more energy you need to accelerate further. As you approach light speed, your mass approaches infinity, which means the energy required to push you that final bit faster also approaches infinity. Let's put this into perspective with some real numbers that will blow your mind. If you could somehow accelerate a single kilogram of matter, about the mass of a textbook, to 90% the speed of light, its mass would increase to about 2.3 kilograms. That might not sound like much, but watch what happens as we get closer. At 99% light speed, that same kilogram now has a mass of about 7 kilograms. At 99.9% light speed, it weighs 22 kilograms. At 99.99%, it's 71 kilograms. At 99.999%, it's 224 kilograms. You can see the pattern here. The mass is growing exponentially, and we're still not even close to light speed. Now imagine trying to accelerate not just a kilogram, but an entire spacecraft weighing thousands of tons, along with a human body weighing dozens of kilograms. The energy requirements become so astronomical that they quickly exceed the total energy output of entire stars. To accelerate just 1 kilogram to 99.9999%, the speed of light would require more energy than our sun produces in several years. To reach actual light speed would require infinite energy, which is physically impossible to obtain anywhere in the universe. Even if you could somehow harness the energy of every star in the observable universe, you still wouldn't have enough to push a single atom to light speed. This energy barrier exists for profound reasons that go to the heart of how reality operates. The universe isn't arbitrary in setting this speed limit. It's protecting the fundamental structure of space and time. If objects with mass could reach light speed, the mathematical equations that describe reality would break down completely. Division by zero would occur in the formulas that govern time dilation and length contraction, creating mathematical infinities that have no physical meaning. The universe would literally stop making sense. But the mass increase isn't the only barrier preventing light speed travel. As you accelerate toward this cosmic speed limit, the very space around you begins to behave in increasingly bizarre ways. The Lorentz transformation, which describes how space and time change at high velocities, reveals that distances in the direction of travel begin contracting. At first, this contraction is barely noticeable. At 10% light speed, distances contract by only 0.5%. But as you get closer to light speed, this effect becomes dramatic. At 90% light speed, distances contract to about 44% of their original length. At 99%, they shrink to 14%. At 99.9%, just 4.5% remains. This length contraction affects everything: your spacecraft, your body, the space between atoms in your hull, even the electromagnetic fields that hold matter together. As you approach light speed, your spacecraft becomes increasingly pancaked in the direction of travel. From an outside observer's perspective, you would appear to flatten like a piece of paper, becoming thinner and thinner until you're compressed to an infinitesimal thickness. But here's the truly mind-bending part. From your perspective inside the spacecraft, you wouldn't notice this contraction at all. Your measuring instruments would contract along with everything else, so distances would still appear normal to you. The time effects are equally dramatic and far more disturbing. As your velocity approaches light speed, time itself begins to slow down relative to the outside universe. This isn't just a theoretical effect. It's been measured with atomic clocks on high-speed aircraft and is so significant that GPS satellites must correct for it to maintain accuracy. At 90% light speed, time slows to about 44% of normal rate. This means that for every hour that passes on your spacecraft, about 2.3 hours pass in the outside world. At 99% light speed, time slows to just 14% of normal rate. For every hour you experience, the outside world ages by about 7 hours. As you push closer to light speed, this time, dilation effect becomes increasingly extreme. At 99.9% light speed, for every hour you experience, the outside world ages by about 22 hours. At 99.99%, it's about 71 hours. The mathematical relationship shows that as you approach light speed, time dilation approaches infinity. This means that at actual light speed, no time would pass for you, while infinite time passes for the rest of the universe. You would exist in a state of temporal suspension while everything you've ever known ages and dies instantaneously from your perspective. The physics behind these effects reveal something profound about the nature of reality itself. Space and time aren't separate, independent dimensions as our everyday experience suggests. They're woven together into a single fabric called space-time, and this fabric has built-in limitations that prevent causality violations and paradoxes. The speed of light isn't just the speed at which light travels. It's the speed at which causality itself propagates through the universe. It's the maximum rate at which information can travel from one point to another, ensuring that cause always precedes effect. If you could somehow exceed light speed, you could theoretically travel backward in time, creating paradoxes that would tear apart the logical structure of reality. You could arrive at your destination before you left, or even prevent your own departure. The universe's speed limit isn't just a physical constraint. It's a logical necessity that preserves the coherent flow of time and causation. Einstein didn't discover an arbitrary rule. He uncovered a fundamental principle that keeps reality itself from collapsing into contradiction. The energy requirements for approaching light speed become clearer when we examine what happens in particle accelerators, the closest thing we have to light speed travel in practice. The Large Hadron Collider at CERN can accelerate protons to 99.999991%, the speed of light, using superconducting magnets and enormous amounts of electrical energy. Even at this incredible velocity, the protons still fall short of light speed by a tiny fraction. To push them that final infinitesimal bit faster would require infinite energy, which is why even our most advanced technology hits this ultimate wall. Consider the practical implications of trying to build a light-speed spacecraft. Even if we could somehow solve the infinite energy problem, we would face insurmountable engineering challenges. The spacecraft would need to be constructed from materials that could withstand infinite stress as their mass approached infinity. The structural integrity would need to remain intact while the entire vessel contracted to zero length in the direction of travel. The life support systems would need to function normally while experiencing infinite time dilation. These aren't just difficult engineering problems. They're logical impossibilities that no amount of technological advancement could overcome. The impossibility of light speed travel also protects us from devastating consequences that would occur if such travel were possible. Any object with mass traveling at light speed would carry infinite kinetic energy. The collision of such an object with anything, even a single atom of hydrogen floating in space, would release infinite energy, essentially destroying the universe. The cosmic speed limit isn't just preventing us from going fast, it's preventing us from accidentally annihilating everything that exists. But perhaps the most beautiful aspect of this impossibility is what it reveals about the elegant structure of physics itself. The same equations that prevent massive objects from reaching light speed are the ones that allow massless particles like photons to travel at exactly this speed and no faster. Light doesn't gradually accelerate to this velocity. It's created traveling at light speed and can never slow down. This creates a perfect symmetry in nature. Particles with mass can approach but never reach light speed, while particles without mass must travel at light speed and can never go slower. This fundamental barrier also explains why the universe appears the way it does to us. If light speed travel were possible for massive objects, stars could zip around the galaxy at will, planets could change orbits instantly, and the stable structures we see in the cosmos couldn't exist. Gravity would operate differently. Chemical reactions would behave unpredictably, and the delicate balance that allows life to exist would be impossible. The speed limit doesn't just govern motion, it governs the entire architecture of reality, from the smallest atomic interactions to the largest galactic structures. The mathematical beauty of this impossibility extends even deeper when we consider the relationship between space and time. Einstein showed us that these aren't fixed stages on which events play out, but dynamic dimensions that bend and flex with motion and gravity. The speed of light represents the rate at which this space-time fabric can transmit information and maintain its coherent structure. Exceeding this speed wouldn't just break the rules of physics, it would shatter the very foundation upon which physics is built. So as we prepare to imagine breaking this ultimate barrier and experiencing light speed travel anyway, remember that we're not just bending the rules of physics. We're entering a realm where the fundamental logic of reality breaks down. What we're about to explore exists beyond the boundary of the possible, in a theoretical space where mathematics meets meaninglessness and where the protective barriers of natural law no longer apply. The universe has very good reasons for preventing this journey, and as we'll discover, those reasons become terrifyingly clear once we cross the line into the impossible. Now that we've established the impossibility of reaching light speed, let's break physics and imagine we've somehow achieved this ultimate velocity anyway. The moment your spacecraft hits exactly 299,792,458 meters per second, something extraordinary and terrifying happens to your relationship with time itself. Time dilation, which you've already experienced in increasingly dramatic forms as you approach light speed, now reaches its absolute extreme. At light speed, the mathematical equations that govern time dilation produce a result that fundamentally alters your existence in ways that are both fascinating and deeply disturbing. To understand what happens to time at light speed, we need to examine the Lorentz factor, the mathematical relationship that determines how much time slows down at high velocities. This factor is calculated using the equation gamma equals 1 divided by the square root of 1 minus velocity squared divided by the speed of light squared. As your velocity approaches the speed of light, the denominator of this fraction approaches zero, which means the Lorentz factor approaches infinity. At exactly light speed, this mathematical relationship breaks down completely, producing an infinite result that has profound implications for your experience of time. When the Lorentz factor becomes infinite, time dilation reaches its ultimate extreme. From your perspective aboard the Lightspeed spacecraft, time doesn't just slow down dramatically, it stops completely. Every clock on your ship freezes. Every atomic vibration that marks the passage of time ceases to tick forward. Every biological process that depends on temporal progression comes to a halt. You exist in a state of perfect temporal suspension, where no time passes whatsoever. This isn't just extremely slow time. This is the complete absence of temporal flow, a state where the concept of duration becomes meaningless. But while time stops for you, the rest of the universe continues aging at its normal rate. This creates a temporal paradox that is both mathematically precise and emotionally devastating. Every second that passes in the outside world, and there will be countless seconds, minutes, hours, years, centuries, and millennia, occurs while you experience absolutely no passage of time. From your frozen temporal perspective, the entire future history of the universe unfolds instantaneously. Every person you've ever known lives their complete remaining lifespan in what feels like zero time to you. Let's explore what this means for everyone you've left behind on Earth. The moment you reach light speed, from your perspective, you would witness the rest of their lives occurring simultaneously. Your family members would age, have children, grow old, and pass away in what appears to be an instant. Their children would do the same, and their children after them. Generations would rise and fall while you remain suspended in your single moment of light speed travel. The temporal disconnect is so extreme that calling it heartbreaking doesn't begin to capture the emotional magnitude of what you're experiencing. The mathematical relationship reveals just how extreme this temporal separation becomes. While you experience zero time, the outside universe experiences normal time flow. This means that any journey you take at light speed, regardless of the distance, occurs instantaneously from your perspective, while taking the normal amount of time from the universe's perspective. If you traveled to a star 4 light years away, the journey would feel instantaneous to you, but 4 years would pass on Earth. If you traveled to the center of our galaxy, about 26,000 light years away, no time would pass for you, but 26,000 years would elapse on Earth. The entire recorded history of human civilization spans only about 5,000 years, so your journey to the galactic center would witness the rise and fall of more than 5 complete cycles of human civilization. This temporal extreme creates scenarios that challenge our understanding of existence itself. Consider what happens to your consciousness during light speed travel. If no time passes for you, can you actually experience the journey? Experience requires temporal flow, the progression from one moment to the next, the ability to form thoughts that develop over time, the capacity to process information as it changes. At light speed, with time completely stopped, the very notion of experience becomes paradoxical. You would exist in a state that transcends normal consciousness, suspended in a single instant that contains no duration. The biological implications of this temporal freeze are equally mind-bending. Every cellular process in your body depends on time to function. Your heart beats in temporal sequence. Your neurons fire in timed patterns. Your blood flows through vessels over duration. At light speed, all of these processes would be frozen in time. You wouldn't age because aging requires temporal progression. You wouldn't think because thinking requires time to move from one neural state to another. You wouldn't even decay because decay is a temporal process. You would exist in a state of perfect biological preservation, suspended in the exact instant you reach light speed. But this raises profound questions about identity and continuity of self. If no time passes for you during the journey, are you the same person when you somehow return to normal speeds? From your perspective, no experiences would have occurred during the light speed travel. No memories would have formed. No thoughts would have been completed. You would transition instantly from the moment of reaching light speed to the moment of returning to normal velocity, with no subjective experience of the journey itself. The person who returns would be identical to the person who left, preserved in perfect temporal suspension. Meanwhile, the universe around you continues its relentless march through time. Stars continue their nuclear fusion processes. Planets orbit their suns. Galaxies rotate and collide. The cosmic microwave background radiation continues cooling as the universe expands. Dark energy keeps pushing space apart at an accelerating rate. All of these processes, which normally take millions, billions, or trillions of years to produce noticeable changes, would appear to happen instantly from your light speed perspective. The emotional weight of this temporal separation becomes even more staggering when we consider longer journeys. Imagine traveling to the Andromeda Galaxy, our nearest major galactic neighbor, located about 2.5 million light years away. From your perspective, the journey would be instantaneous, requiring no time at all. But 2.5 million years would pass on Earth. To put this in perspective, 2.5 million years ago, early humans were just beginning to use stone tools. Modern humans didn't even exist yet. Your entire species could evolve, develop civilization, explore the cosmos, and potentially go extinct multiple times over during your instantaneous journey. The mathematical beauty of this extreme time dilation reveals something profound about the structure of space-time itself. Time isn't a universal constant flowing at the same rate everywhere. It's intimately connected to motion and energy through the fabric of space-time. At light speed, you've reached the point where this fabric behaves in its most extreme way possible. You've touched the boundary where time transitions from flowing slowly to not flowing at all, where the normal rules of temporal progression break down completely. This temporal extreme also explains why photons, the particles that make up light, don't experience time in the way we understand it. From a photon's perspective, its entire journey, from creation to absorption, occurs instantaneously, regardless of the distance traveled. A photon created in the core of the sun takes about 100,000 years to random walk its way to the sun's surface, then about 8 minutes to travel to Earth. But from the photon's perspective, this entire 100,000-year journey happens in zero time. The photon experiences its creation and absorption as simultaneous events, with no temporal separation between them. The implications extend to our understanding of causality and the flow of information through the universe. At light speed, you would exist at the boundary where cause and effect begin to break down. Normal causation requires temporal sequence. Causes must precede their effects in time. But when no time passes, this sequence becomes meaningless. You would exist in a state where past, present, and future lose their distinct meanings, where the normal arrow of time that gives structure to reality becomes irrelevant. This temporal suspension also affects your relationship with the physical universe in unexpected ways. Electromagnetic radiation, which includes everything from radio waves to gamma rays, travels at the speed of light. When you join this electromagnetic realm, by reaching light speed, you become part of the same reference frame as all electromagnetic phenomena. Light waves that would normally pass by you at light speed now appear frozen from your perspective, while you appear to be traveling alongside them as companions in this timeless state. The energy implications of this temporal extreme are equally fascinating. Einstein's famous equation E equals mc squared shows us that mass and energy are interchangeable. At light speed, with infinite time dilation, the energy relationships that govern normal matter behavior reach their breaking point. Your mass, which approached infinity as you reach light speed, now exists in a state that transcends normal mass-energy relationships. You've become something that exists outside the normal categories of matter and energy that define the physical universe. Consider what this means for your perception of distance and space during light-speed travel. Since no time passes for you, any journey appears to take zero time regardless of the distance involved. This creates a strange relationship with space, where all distances become equivalent from your perspective. Whether you're traveling 1 meter or 1 billion light years, the subjective experience is identical. No time passes. Distance becomes a meaningless concept when duration doesn't exist to measure travel time. The return journey from light speed presents its own temporal mysteries. How do you transition from a state where no time passes back to normal temporal flow? The mathematics suggests that this transition would be as dramatic as reaching light speed in the first place. You would suddenly jump from timeless existence back into the normal flow of temporal progression, potentially experiencing a jarring discontinuity as your consciousness readjusts to the passage of time. This temporal extreme also reveals why the universe protects itself by making light-speed travel impossible for massive objects. If such travel were possible, it would create temporal paradoxes that could shatter causality itself. Imagine if you could travel backward in time by exceeding light speed, then return to your starting point before you left. The logical contradictions this would create would undermine the rational structure of reality itself. The psychological implications of experiencing infinite time dilation are perhaps the most disturbing aspect of this impossible journey. Even if you could somehow maintain consciousness during light speed travel, the knowledge that infinite time is passing in the outside world while you experience none would be psychologically devastating. Every instant of your journey would contain the knowledge that countless lives are being lived and lost while you remain frozen in temporal suspension. As we prepare to explore the next consequence of light speed travel, the extreme length contraction that would compress space itself, remember that these temporal effects aren't just mathematical curiosities. They represent fundamental aspects of reality that reveal how intimately connected time, space, motion, and existence truly are. The extreme time dilation at light speed shows us that time isn't just a dimension we move through. It's the very foundation that makes experience, consciousness, and existence possible. Without temporal flow, we transcend not just the normal rules of physics, but the basic conditions that make life meaningful. While your experience of time has completely stopped at light speed, something equally dramatic and disturbing is happening to space itself. Length contraction, the companion effect to time dilation, now reaches its own impossible extreme, fundamentally altering the geometry of reality around you. Just as time dilation approached infinity as you reached light speed, length contraction also approaches its mathematical limit, compressing distances in the direction of your travel to zero. This isn't just a minor adjustment to measurements. This is the complete collapse of spatial dimensions, transforming the three-dimensional universe into something unrecognizable and terrifying. The mathematics of length contraction follows the same Lorentz transformation that governs time dilation, but it affects space rather than time. As your velocity approaches light speed, distances in the direction of your motion contract according to the equation L equals L0 times the square root of 1 minus velocity squared divided by the speed of light squared. When your velocity equals the speed of light, this equation produces a result of 0, meaning that all distances in your direction of travel have contracted to literally nothing. This mathematical reality creates a spatial nightmare that defies every intuitive understanding of how space should behave. From the perspective of an outside observer watching your light speed journey, your spacecraft would appear to flatten completely in the direction of travel. If your ship was originally 100 meters long, it would compress to zero length while maintaining its width and height. You would appear as a two-dimensional object, a flat plane with no thickness whatsoever in the direction you're moving. But this flattening isn't just visual. It represents a fundamental change in the spatial properties of your spacecraft and everything inside it, including your own body. Your physical form undergoes the same extreme contraction. Your body, which normally extends some distance from head to toe or front to back, depending on your orientation, would compress to zero thickness in the direction of travel. Every organ, every bone, every cell, and every molecule in your body would be squeezed into a two-dimensional plane. The spacing between atoms in your tissues would contract to nothing, yet somehow the electromagnetic forces that hold matter together would need to continue functioning across this compressed space. This creates a paradox where matter must maintain its structural integrity while occupying zero volume in one dimension. But the truly mind-bending aspect of length contraction at light speed isn't what happens to you. It's what happens to the universe around you. Every distance ahead of you in the direction of travel contracts to zero. The space between Earth and the nearest star, about 4.2 light-years under normal conditions, compresses to nothing. The diameter of our galaxy, normally about 100,000 light-years across, shrinks to zero thickness. The distance to the most remote galaxies we can observe, billions of light-years away, all contract to the same zero dimension. From your perspective, the entire observable universe in your direction of travel has collapsed into a flat, two-dimensional plane. This spatial collapse creates a navigation nightmare that makes any destination meaningless. When all distances in your direction of travel have contracted to zero, every possible destination exists at the same location from your perspective. The moon, the sun, the center of our galaxy, and the edge of the observable universe all occupy the same compressed space directly in front of you. Traditional concepts of near and far become completely irrelevant when spatial separation has been eliminated. You cannot aim for a specific destination because all destinations have merged into a single dimensionless point. The electromagnetic fields that hold atoms together and allow matter to exist must somehow continue functioning across this contracted space. Chemical bonds, which normally span specific distances between atoms, now must maintain their integrity across zero distance. The electron clouds that surround atomic nuclei, which define the size and shape of atoms, must somehow exist in a space that has no thickness. This creates fundamental questions about whether matter can continue to exist in a recognizable form. When the spatial dimensions that define its structure have collapsed to nothing. From your contracted perspective inside the spacecraft, however, space appears completely normal. This is one of the most profound aspects of relativity. Observers always measure space and time as normal in their own reference frame. Your measuring instruments contract along with everything else, so distances still appear to have their normal values to you. The length of your spacecraft, the size of your body, the spacing between objects, everything maintains its familiar proportions from your perspective. You have no direct way to detect that you've been compressed to zero thickness because your measuring tools have undergone the same compression. But while space appears normal to you, the universe outside presents a radically different picture. The cosmic background radiation, which normally comes from all directions as a faint afterglow of the Big Bang, now appears concentrated into a narrow beam directly ahead of you. Light from stars and galaxies, which normally arrives from various angles across the sky, has been compressed into this same forward direction. The entire electromagnetic spectrum of the universe has been focused into a narrow cone of radiation streaming toward your position. This compression of electromagnetic radiation creates its own set of problems. Light waves that were once spread across vast regions of space are now concentrated into an infinitesimally narrow beam. The energy density of this radiation becomes enormous as all the photons that were once distributed across three-dimensional space are squeezed into a two-dimensional plane. Radio waves, visible light, infrared radiation, ultraviolet light, X-rays, and gamma rays from across the universe all converge into this compressed forward direction, creating an incredibly intense beam of electromagnetic energy. The spatial contraction also affects the fundamental forces that govern the universe. Gravity, which normally acts across three-dimensional space according to the inverse square law, must now operate in a universe where one dimension has collapsed to zero. The electromagnetic force, which holds atoms together and allows chemistry to function, must work across distances that have contracted to nothing. The strong nuclear force that binds protons and neutrons together in atomic nuclei must maintain its grip across zero spatial separation. These forces evolved to work in three-dimensional space, and their behavior in a dimensionally collapsed universe becomes unpredictable. Consider what happens to the matter that makes up planets, stars, and galaxies in this contracted space. A planet like Earth, normally about 12,800 kilometers in diameter, would be compressed to zero thickness in your direction of travel, while maintaining its full width and height in the perpendicular directions. Every mountain, ocean, continent, and atmospheric layer would be squeezed into a flat disk with no depth. The planet's mass would remain the same, but it would be distributed across a two-dimensional surface rather than a three-dimensional volume. Stars present an even more dramatic example of this spatial compression. Our Sun, normally about 1.4 million kilometers in diameter, would flatten to zero thickness while retaining its full width and height as seen from the side. The nuclear fusion reactions in the stellar core, which depend on the enormous pressures created by gravitational compression across three-dimensional space, would now occur in a flattened geometry where one dimension has vanished entirely. The mechanisms that power stars and create the elements necessary for life would need to function in this impossible compressed geometry. Entire galaxies, normally vast three-dimensional structures spanning hundreds of thousands of light years, would appear as flat disks with no thickness in your direction of travel. The spiral arms that define galaxies like our Milky Way would be compressed into two-dimensional patterns. The central black holes that anchor most galaxies would need to maintain their gravitational influence across space that has been reduced to two dimensions. The dark matter, halos that provide the gravitational scaffolding for galaxy formation, would be flattened into two-dimensional sheets. The quantum mechanical effects that govern the behavior of matter at the smallest scales also become problematic in this contracted space. Heisenberg's uncertainty principle, which relates the precision of position and momentum measurements, depends on the three-dimensional nature of space. When one spatial dimension collapses to zero, the quantum behavior of particles becomes unpredictable. Wave functions that describe the probability distributions of particle locations must somehow exist in a space where one dimension has no extent. This spatial compression creates fundamental problems for the basic building blocks of matter. Electrons in atoms occupy specific orbitals that have three-dimensional shapes defining where the electrons are likely to be found. When space contracts to zero in one direction, these orbitals must somehow maintain their structure while being compressed to two-dimensional surfaces. The chemical bonds that hold molecules together depend on the three-dimensional arrangement of atoms. But these arrangements become meaningless when spatial extent in one direction has vanished. The speed of light itself, which defines the rate at which information can travel through space, becomes problematic in this contracted geometry. Light normally propagates through three-dimensional space, but when one dimension has collapsed to zero, electromagnetic waves must somehow continue functioning in the remaining two dimensions. The wave equations that describe how light travels through space were developed for three-dimensional geometry and may not have meaningful solutions when spatial extent in one direction has disappeared entirely. Even more disturbing is what this spatial collapse means for the concept of volume. Volume, which measures the amount of three-dimensional space occupied by an object, becomes meaningless when one dimension has contracted to zero. Your spacecraft, no matter how large it was originally, now occupies zero volume in the direction of travel. Your body, which normally displaces a specific amount of space, now has zero volume in one dimension. The entire universe in your direction of travel has zero volume, meaning that all the matter and energy it contains must somehow exist in a space with no three-dimensional extent. The mathematical description of this spatial collapse reveals the deep connection between geometry and reality. Space isn't just an empty stage where physical events occur. It's an active participant in the laws of physics. The shapes of objects, the distances between particles, the volumes occupied by matter, all of these geometric properties are essential for the normal operation of physical laws. When geometry breaks down through extreme length contraction, the very foundation of physics becomes unstable. This spatial nightmare also demonstrates why the universe protects itself by making light-speed travel impossible. If objects with mass could actually reach light speed and experience this spatial collapse, the three-dimensional structure of space that makes normal physics possible would break down. Chemical reactions couldn't occur normally. Gravitational attraction would behave unpredictably, and the quantum mechanical processes that govern atomic behavior would cease to function reliably. The length contraction at light speed represents more than just a distortion of measurement. It's a fundamental breakdown of the spatial framework that makes existence possible. In this compressed geometry, the concepts of shape, size, distance, and volume lose their meaning. The universe transforms from a vast three-dimensional expanse into a flat, two-dimensional plane, where all of space in your direction of travel has collapsed into nothingness. This spatial catastrophe, combined with the temporal freeze we explored earlier, shows us why light speed represents not just a velocity limit, but a boundary beyond which the normal structure of reality cannot survive. Now that we've explored the catastrophic effects of time stopping and space collapsing at light speed, let's dive deeper into what it truly means to exist at this ultimate velocity by examining the experience of particles that naturally travel at light speed. Photons. These massless particles of light have been racing through the universe at exactly 299,792,458 meters per second since the moment of their creation, and their existence reveals the most profound and mind-bending aspects of what you would experience during impossible light-speed travel. By understanding the photon's journey through space and time, we can glimpse into the alien realm of light-speed existence and discover truths about reality that challenge our deepest assumptions about the nature of experience itself. Photons exist in a reference frame that is completely foreign to our everyday understanding of reality. From the moment a photon is created, whether in the nuclear furnace of a star, the heated filament of a light bulb, or the quantum transition of an excited atom, it immediately begins traveling at light speed and can never slow down or speed up. This isn't because photons accelerate to light speed. They are created already traveling at this ultimate velocity and have no choice but to maintain it throughout their entire existence. This creates a form of existence that is both eternal and instantaneous, both infinite and immediate. From a photon's perspective, something extraordinary happens to the experience of time and space that mirrors what you would encounter at light speed. Time dilation reaches its absolute maximum for photons, meaning that no time passes during their journey, regardless of the distance they travel. A photon, created in the core of a distant star billions of years ago, and reaching Earth today, experiences no passage of time between its creation and its absorption by your eye. From the photon's point of view, these two events, its birth in a stellar core billions of years in the past and its detection in the present moment, are simultaneous occurrences separated by zero time. This timeless existence means that every photon in the universe experiences all of cosmic history as a single, instantaneous moment. Photons created during the first few 100,000 years after the Big Bang, when the universe cooled enough for light to travel freely, still journey through space today as the cosmic microwave background radiation. From their perspective, the entire 13.8 billion year history of the universe since their creation has passed in zero time. They exist as witnesses to cosmic history, but witnesses who experience that entire history as happening all at once in a single moment. The spatial experience of photons is equally alien and mirrors the length contraction nightmare you would face at light speed. From a photon's reference frame, all distances in the direction of travel contract to zero. This means that every photon, regardless of how far it travels from our perspective, experiences zero distance during its journey. A photon traveling from the Sun to Earth covers 93 million miles from our perspective, taking about 8 minutes to make the journey. But from the photon's perspective, this distance contracts to zero, making the journey instantaneous across no space at all. This zero distance experience applies to photons traveling any distance in the universe. Consider photons from the most distant galaxies we can observe, located more than 13 billion light years away. These photons have been traveling through space for most of the age of the universe, crossing distances so vast that they challenge our ability to comprehend them. Yet from the photon's perspective, they experience zero distance during their journey. The source galaxy and Earth exist at the same location in their contracted spatial framework, separated by no distance whatsoever. The implications of this timeless, spaceless existence become even more profound when we consider what it means for consciousness and experience. If you could somehow maintain awareness while traveling at light speed, you would share this photon-like existence where time doesn't pass and distance doesn't exist. Your journey from Earth to the most distant observable galaxy would feel instantaneous to you, requiring no time and covering no distance from your perspective. You would exist in a state similar to photons, where the concepts of duration and separation lose all meaning. But photons reveal something even more mysterious about light speed existence through their quantum mechanical properties. Unlike massive objects that have definite positions and velocities, photons exist as waves of electromagnetic energy that are spread out across space. When a photon travels from one location to another, it doesn't follow a single path like a tiny bullet. Instead, it exists as a wave that simultaneously explores all possible paths between its source and destination. This wave-like nature means that a photon's journey involves a kind of existence that transcends our normal understanding of traveling from point A to point B. This wave property of photons suggests that your light speed experience would involve more than just moving very fast from one location to another. You would exist in a quantum state where your journey simultaneously explores all possible paths through space. Every route between your starting point and destination would be equally real from your perspective. You wouldn't travel along a single trajectory, but would exist as a wave-like entity that encompasses all possible ways of making the journey, only collapsing into a definite path when your journey ends. The quantum nature of photons also reveals how information and energy behave at light speed. When a photon carries information, such as the light from a distant star that tells us about the star's composition, temperature, and motion, that information exists in a timeless state during the journey. From the photon's perspective, the information is transmitted instantaneously across zero distance. The star's light carries details about nuclear fusion reactions, magnetic field fluctuations, and atmospheric composition. But this information exists in a suspended state where past and present merge into a single moment. This information transmission property suggests that your light speed consciousness would have access to a unique perspective on causality and information flow. Events that appear separated in time and space from normal perspectives would appear simultaneous and co-located from your light speed reference frame. You would exist at the boundary where cause and effect, past and future, here and there lose their distinct meanings and merge into a unified, timeless present. Photons also demonstrate how energy behaves at light speed through their relationship with electromagnetic fields. Every photon is a localized disturbance in the electromagnetic field that fills all of space. When you reach light speed, you would join this electromagnetic realm, becoming part of the same field that carries radio waves, visible light, X-rays, and gamma rays throughout the universe. Your existence would merge with the electromagnetic forces that bind atoms together, power chemical reactions, and transmit information across cosmic distances. This electromagnetic existence reveals another aspect of the photon experience: the complete unity with the fundamental forces of nature. Photons don't just carry electromagnetic energy, they are electromagnetic energy in its purest form. At light speed, you would transcend the normal categories of matter and energy that define everyday existence. You would become pure energy, existing as a disturbance in the fabric of space-time itself, rather than as matter moving through space. The photon experience also illuminates the relationship between energy and frequency that governs all electromagnetic radiation. Higher energy photons vibrate at higher frequencies, while lower energy photons vibrate at lower frequencies. But from the photon's timeless perspective, these frequency differences represent eternal characteristics rather than temporal vibrations. A gamma-ray photon doesn't experience its high-frequency oscillation as rapid vibration over time because no time passes for the photon. Instead, the high frequency exists as a timeless property that defines the photon's nature throughout its instantaneous existence. This frequency relationship suggests that your light speed experience might involve existing at a specific energy frequency that defines your nature during the journey. Just as photons exist as electromagnetic waves with characteristic frequencies, you might exist as a matter wave with its own frequency signature. This wave nature would spread your existence across space and time in ways that transcend normal concepts of location and duration. The interaction between photons and matter provides another window into the light speed experience. When a photon encounters an electron in an atom, it can transfer its energy instantaneously, causing the electron to jump to a higher energy state. From the photon's perspective, its entire existence, from creation to absorption, occurs in this single moment of interaction. There is no journey time, no gradual approach to the target, no passage through intervening space. Creation, travel, and absorption are simultaneous events in the photon's reference frame. This instantaneous interaction suggests that your light speed journey would involve a similar collapse of temporal sequence. Your departure, travel, and arrival would all occur simultaneously from your perspective. The normal narrative structure of journeys, beginning, middle, and end, would compress into a single unified moment where all phases of the trip happen at once. Photons also reveal the deep connection between observation and reality at light speed. In quantum mechanics, photons exist in superposition states where they simultaneously possess multiple properties until they interact with matter and collapse into definite states. A photon can simultaneously have multiple polarizations, follow multiple paths, and carry multiple pieces of information until the moment it's observed or measured. This suggests that your light speed existence might involve a similar superposition where you simultaneously exist in multiple states until your journey ends. The photon experience extends to their role in mediating fundamental forces. The electromagnetic force that holds atoms together and powers chemical reactions operates through the exchange of virtual particles, photons. These photons exist for such brief periods that they never travel far enough to be directly detected, but they carry the electromagnetic force between charged particles. At light speed, you would exist in the same realm as these virtual particles, participating in the fundamental mechanisms that hold matter together and make chemical reactions possible. This force-carrying role of photons suggests that light speed existence involves direct participation in the fundamental workings of reality. You wouldn't just be observing the universe from a light speed perspective. You would become part of the basic mechanisms that make the universe function. Your existence would merge with the forces that bind quarks into protons, electrons to nuclei, and atoms into molecules. The collective behavior of photons in phenomena like laser light and coherent radiation reveals another aspect of light speed existence. When photons are coherent, they act together as a unified wave rather than as individual particles. This collective behavior suggests that light-speed existence might involve losing individual identity and merging into larger patterns of energy and information. Your personal consciousness might expand to encompass broader aspects of the electromagnetic field, experiencing reality from a perspective that transcends individual existence. As we prepare to explore the devastating collision effects that would occur during light-speed travel, remember that the photon experience reveals light-speed existence as something far more alien and profound than simply moving very fast. It represents a form of existence where time and space lose their meaning, where individual identity merges with fundamental forces, and where the normal categories of experience break down completely. The photon's timeless, spaceless journey through the universe shows us that light-speed existence transcends not just the limits of velocity, but the basic conditions that make normal experience possible. While the temporal and spatial effects of light-speed travel create a surreal and alien existence, the collision consequences represent perhaps the most immediately dangerous and catastrophic aspect of this impossible journey. At light speed, every particle of matter you encounter, no matter how small or seemingly harmless, becomes a weapon of unimaginable destructive power. The physics of high-energy collisions transforms the empty vacuum of space into a deadly obstacle course, where even individual atoms become cosmic bullets, capable of annihilating your spacecraft and everything in it. Understanding these collision effects reveals why the universe's speed limit isn't just a mathematical curiosity. It's a protective barrier that prevents matter from becoming a universe-destroying force. The fundamental principle behind these catastrophic collisions lies in Einstein's famous relationship between mass, velocity, and kinetic energy. Under normal circumstances, kinetic energy equals 1/2 times mass times velocity squared. This relationship works well for everyday speeds, but it breaks down completely as velocities approach light speed. At relativistic velocities, the kinetic energy formula becomes much more complex, incorporating the Lorentz factor that we've encountered in time dilation and length contraction. As velocity approaches light speed, the kinetic energy approaches infinity, meaning that any collision becomes infinitely destructive. Let's begin with the most abundant particles you'll encounter during light speed travel: hydrogen atoms floating freely in the vacuum of space. Interstellar space isn't truly empty. It contains roughly 1 hydrogen atom per cubic centimeter. Under normal conditions, these atoms are essentially invisible and harmless, posing no threat to spacecraft traveling at conventional velocities. But when you're moving at light speed, each of these innocent hydrogen atoms becomes a cosmic projectile carrying enormous kinetic energy. From your spacecraft's perspective, these stationary hydrogen atoms are approaching you at light speed, giving them infinite kinetic energy in your reference frame. The collision between your light-speed spacecraft and a single hydrogen atom would release energy equivalent to the most powerful nuclear weapons ever built. The proton in the hydrogen nucleus, with its tiny mass of about 1.67 times 10 to the negative 27 kilograms, would carry kinetic energy approaching infinity as it strikes your spacecraft at light speed. This collision would release energy levels comparable to the nuclear reactions that power stars concentrated into a single point of impact on your spacecraft's hull. The electromagnetic forces that normally hold atoms together would be completely overwhelmed by the enormous energies involved in this cosmic collision. But hydrogen atoms are just the beginning of your collision nightmare. Space also contains heavier elements: carbon atoms, oxygen atoms, iron atoms, scattered by stellar winds and supernova explosions throughout the galaxy. Each of these heavier atoms carries proportionally more mass, which means proportionally more kinetic energy when encountered at light speed. A single carbon atom, with its 12 protons and neutrons, would hit your spacecraft with 12 times the energy of a hydrogen atom. An iron atom, with its 56 nucleons, would deliver 56 times the destructive power. These collisions would create explosions that dwarf anything possible with conventional nuclear weapons. The collision effects become even more devastating when we consider dust particles, which are common throughout interstellar space. A typical dust grain might contain millions or billions of atoms clustered together into a microscopic particle. When this dust grain encounters your light-speed spacecraft, it delivers the combined kinetic energy of all its constituent atoms simultaneously. The explosion would be equivalent to detonating multiple nuclear weapons at the point of impact, instantly vaporizing any material it touches and sending shock waves throughout your spacecraft's structure. The physics of these high-energy collisions involves processes that normally only occur in the most extreme environments in the universe. When particles collide at light speed, the enormous kinetic energies involved are sufficient to break apart atomic nuclei, creating showers of subatomic particles, including protons, neutrons, electrons, and exotic particles that normally exist only for brief moments in particle accelerators. Your spacecraft would be bombarded with radiation levels that exceed anything found naturally, except in the hearts of exploding stars or near the event horizons of black holes. These particle collisions would also produce intense electromagnetic radiation across the entire spectrum. The sudden deceleration of charged particles during impact creates what physicists call Bremsstrahlung radiation, intense bursts of X-rays and gamma rays that would flood your spacecraft with lethal levels of electromagnetic energy. This radiation wouldn't just damage electronic equipment. It would break apart the molecular bonds in organic tissue, destroying any biological material through massive radiation poisoning that occurs faster than cellular repair mechanisms could possibly respond. The cumulative effect of countless atomic collisions would turn your spacecraft into a cosmic particle accelerator, continuously creating high-energy particle showers and electromagnetic radiation. Even if your spacecraft could somehow withstand individual atomic impacts, the steady bombardment of particles encountered during light-speed travel through space would quickly overwhelm any conceivable shielding. The energy being deposited in your spacecraft would accumulate faster than any cooling system could dissipate it, causing temperatures to rise to levels that would melt and vaporize the strongest materials known to science. But the collision catastrophe extends beyond just the particles floating freely in space. Your light-speed journey would also encounter the cosmic microwave background radiation that fills all of space as the afterglow of the Big Bang. Under normal conditions, this background radiation is incredibly faint and cool, with a temperature of about 2.7 degrees above absolute zero. But when you're traveling at light speed, This radiation undergoes extreme relativistic Doppler shift, transforming from harmless microwave photons into deadly high-energy gamma rays. The relativistic Doppler effect causes electromagnetic radiation to change frequency when observed from a moving reference frame. As your velocity approaches light speed, the cosmic microwave background radiation in front of you would be blue shifted to increasingly higher frequencies. What starts as cool microwave radiation would transform into infrared light, then visible light, then ultraviolet radiation, then X-rays, and finally into gamma rays, with energies high enough to penetrate any material and destroy atomic nuclei through photodisintegration. This transformation of the cosmic background radiation into a gamma ray death beam represents one of the most insidious aspects of light speed travel. You cannot shield against this radiation because it comes from all directions simultaneously, and no material can provide adequate protection against the intense gamma ray bombardment you would encounter. The radiation would penetrate deep into your spacecraft, breaking apart atomic nuclei and creating cascades of secondary radiation that would make survival impossible even for brief periods. The magnetic fields that permeate space would also become deadly hazards during light-speed travel. Interstellar magnetic fields, which are normally too weak to have any noticeable effect on matter, would interact catastrophically with your light-speed motion. As you move through these magnetic fields at light speed, you would generate enormous electric fields through electromagnetic induction. These induced electric fields would accelerate any charged particles in your vicinity to extreme velocities, creating additional particle bombardment and electromagnetic radiation. The solar wind, a stream of charged particles constantly flowing from our sun and other stars, would become another source of high-energy collisions. Under normal conditions, solar wind particles travel at speeds of a few hundred kilometers per second, making them easily deflected by magnetic shielding. But when encountered at light speed, these particles would carry relativistic energies comparable to cosmic ray particles, creating additional sources of radiation and particle bombardment that would add to your spacecraft's destruction. Even the quantum vacuum itself becomes hostile at light-speed velocities. Quantum field theory tells us that empty space isn't truly empty, but filled with virtual particles that constantly appear and disappear in accordance with Heisenberg's uncertainty principle. At light speed, your interaction with these virtual particles would be amplified to the point where the vacuum itself becomes a source of resistance and energy loss, similar to how matter experiences drag when moving through a dense medium. The structural integrity of your spacecraft would face impossible challenges under this constant bombardment. Every atomic collision would deposit enormous amounts of energy at the point of impact, creating localized heating that would instantly vaporize material around the collision site. The shock waves from these impacts would propagate through your spacecraft's structure faster than the speed of sound in the material, creating stress fractures and structural failures that would spread throughout the entire vehicle. The electronic systems that control your spacecraft would be among the first casualties of this collision catastrophe. Modern electronics depend on precisely controlled flows of electrons through semiconductor materials, but the intense radiation environment of light-speed travel would overwhelm these delicate systems immediately. The gamma rays and high-energy particles would create massive electrical surges that would destroy computer processors, memory systems, communication equipment, and navigation instruments within moments of reaching light speed. Life support systems would fail catastrophically under these conditions. The oxygen and water recycling systems that keep humans alive in space require complex chemical processes and mechanical equipment that cannot function in the intense radiation environment of light-speed travel. The radiation would break apart air and water molecules, creating toxic compounds that would be lethal even if the primary radiation exposure didn't kill occupants immediately. The human body itself would face destruction from multiple sources during these collisions. The direct radiation exposure would cause massive cellular damage throughout all organ systems simultaneously. The high-energy particles would break apart DNA molecules, destroy cell membranes, and disrupt the chemical processes that maintain life. Even if somehow protected from direct radiation, the indirect effects of electromagnetic pulse generation and structural heating would create an environment incompatible with biological survival. Perhaps most disturbing is the realization that your light-speed spacecraft would itself become a weapon of mass destruction. The kinetic energy you carry while traveling at light speed transforms your vehicle into the equivalent of a cosmic bullet with infinite destructive potential. If your spacecraft somehow collided with a planet, star, or other massive object, the energy release would be sufficient to destroy entire solar systems. You wouldn't just be endangered by collisions. You would become a universe-threatening projectile capable of annihilating anything in your path. This collision catastrophe reveals a profound truth about why the universe maintains its speed limit. If objects with mass could actually reach light speed, they would become cosmic weapons capable of destroying everything they encounter. The energy levels involved in light-speed collisions exceed anything possible through conventional means, making such objects more dangerous than the most powerful supernovas or gamma-ray bursts. The universe's speed limit isn't just protecting you from dangerous travel, it's protecting the universe from you. As we prepare to explore the relativistic Doppler effects that would transform light itself into a weapon during light-speed travel, remember that these collision effects represent just one aspect of why light-speed travel is impossible. The universe has constructed multiple barriers to prevent matter from reaching these velocities, and the collision catastrophe shows us that these barriers exist not just as mathematical curiosities, but as essential protections that preserve the stability and safety of reality itself. While the collision catastrophe represents the immediate physical danger of light-speed travel, an equally terrifying phenomenon would transform your visual and electromagnetic experience into a nightmare of distorted radiation. The relativistic Doppler effect, which causes electromagnetic waves to shift frequency when observed from high-speed reference frames, reaches its most extreme and deadly manifestation at light speed. This effect would not only alter what you see during your impossible journey, but would create lethal radiation environments that would kill you through multiple mechanisms simultaneously. Understanding this Doppler nightmare reveals how light itself becomes weaponized when observed from the ultimate velocity. The Doppler effect is familiar from everyday experience. The change in pitch of a siren as an ambulance passes by, or the shift in radio frequencies when tuning a station while driving. But these ordinary examples pale in comparison to what happens at relativistic speeds, where the Doppler shift becomes so extreme that it fundamentally changes the nature of electromagnetic radiation itself. At light speed, this effect reaches its mathematical limit, creating frequency shifts so dramatic that they transform harmless light into deadly high-energy radiation and cause other wavelengths to disappear entirely from your perception. The mathematical relationship governing relativistic Doppler shift shows that electromagnetic radiation coming toward you from the front increases in frequency by a factor related to your velocity, while radiation coming from behind decreases in frequency by the same factor. As your velocity approaches light speed, this frequency multiplication factor approaches infinity for radiation ahead of you and approaches zero for radiation behind you. This creates a universe where all the electromagnetic energy from the forward direction becomes infinitely blue shifted into high-energy gamma rays, while all the radiation from behind becomes infinitely red shifted toward radio waves and beyond, eventually disappearing from detectable wavelengths entirely. Let's begin with what happens to the light ahead of you during light speed travel. Every source of electromagnetic radiation in your forward direction, stars, galaxies, cosmic background radiation, even the faint infrared glow from interplanetary dust, undergoes extreme blue shifting that transforms it into lethal high-energy radiation. Visible light from distant stars, normally harmless photons that would simply illuminate objects in their path, becomes intense ultraviolet radiation capable of breaking chemical bonds and destroying organic molecules. But the transformation doesn't stop there. As your velocity increases toward light speed, this blue shifted radiation continues climbing the electromagnetic spectrum. Ultraviolet light becomes X-rays with enough energy to penetrate solid matter and ionize atoms throughout your spacecraft. X-rays become gamma rays, with energies sufficient to disrupt atomic nuclei and trigger nuclear reactions in ordinary matter. At actual light speed, this frequency shift becomes infinite, meaning that even the lowest energy radio waves from ahead of you would be transformed into gamma rays with unlimited energy density. The cosmic microwave background radiation, which we discussed earlier as a collision hazard, becomes even more dangerous through relativistic Doppler shifting. This faint afterglow of the Big Bang, normally so weak that it barely registers above absolute zero temperature, would be blue shifted into a forward-focused beam of gamma radiation with intensity that exceeds anything found naturally in the universe, except perhaps in the jets of black holes or the cores of gamma ray bursts. This radiation would approach your spacecraft as a concentrated death beam capable of instantly vaporizing any material it encounters. But the Doppler nightmare extends beyond just increasing the energy of forward radiation. The extreme frequency shift also concentrates all of this high-energy radiation into an increasingly narrow cone directly ahead of your spacecraft. This effect, called relativistic beaming, focuses electromagnetic energy that was originally spread across a wide area of space into a tight beam pointed directly at you. Light from stars and galaxies across a broad region of space ahead of you would be compressed into a narrow cone of intense gamma radiation, creating energy densities that would overwhelm any conceivable shielding. The visual experience of this forward radiation would be both spectacular and terrifying if you could somehow survive long enough to observe it. The normal starlight that creates the familiar patterns of constellations would be shifted far beyond visible wavelengths, disappearing from normal perception. Instead, your forward view would be dominated by intense, brilliant radiation that would appear as a blindingly bright spot directly ahead of your spacecraft, surrounded by an expanding cone of destruction that would destroy your eyes and visual systems instantaneously if you attempted to observe it directly. Meanwhile, the electromagnetic environment behind you would undergo the opposite transformation through red-shifting effects. Light from stars and galaxies behind your spacecraft would be shifted toward longer and longer wavelengths as your velocity approaches light speed. Visible light would first shift into the infrared range, becoming invisible to normal human vision, but still detectable by infrared sensors. As the red shifting effect intensifies, this radiation would continue moving toward longer wavelengths, becoming microwave radiation, then radio waves, and eventually shifting beyond the longest radio wavelengths into ranges that have no practical means of detection. At actual light speed, the red shifting of rear-directed radiation becomes infinite, meaning that all electromagnetic energy from behind your spacecraft would be shifted to infinitely long wavelengths, effectively disappearing from the detectable universe. This creates a bizarre situation where half of the electromagnetic universe simply vanishes from your perception. Stars, galaxies, and cosmic phenomena behind you would fade from view, not because they've been obscured, but because their light has been red-shifted beyond the possibility of detection. This creates a visual nightmare where the universe transforms into a tunnel of death and darkness. The normal 360-degree panorama of stars and cosmic objects would collapse into a narrow cone of intense gamma radiation ahead of you, surrounded by expanding regions of darkness where red-shifted light has disappeared beyond detection. The familiar star patterns that have guided navigation throughout human history would be replaced by a single, brilliant point of deadly radiation that grows more intense and concentrated as your velocity increases. The polarization properties of electromagnetic radiation would also be severely affected by relativistic Doppler effects. Light waves normally vibrate in specific orientations that define their polarization, but extreme Doppler shifting alters these polarization characteristics in ways that would make the radiation even more dangerous. The gamma rays, created by blue shifting, would have polarization properties optimized for penetrating matter and depositing energy deep within materials, making them even more effective at causing destruction than unpolarized radiation of the same energy. The temporal characteristics of electromagnetic pulses would be altered dramatically by these Doppler effects. Light signals that were originally spread out over long time periods would be compressed into brief, intense bursts through time dilation effects combined with Doppler shifting. Radio signals from distant pulsars, which normally arrive as regular pulses spread over seconds or minutes, would be compressed into extremely brief, high-energy pulses that would deliver enormous amounts of energy in microscopic time intervals. The thermal effects of this Doppler-shifted radiation would be catastrophic for any material object. The intense gamma radiation from ahead would deposit energy in your spacecraft's hull at rates that would instantly raise temperatures to levels comparable to stellar cores. No cooling system could possibly dissipate this energy fast enough to prevent complete vaporization of your spacecraft's structure. Even materials with the highest melting points known to science would be instantly converted to plasma by the intense electromagnetic bombardment. The interaction between Doppler-shifted radiation and magnetic fields would create additional hazards during light-speed travel. The intense gamma rays would interact with any magnetic shielding systems, creating cascades of high-energy particles and secondary radiation that would multiply the destructive effects. Magnetic fields that might normally provide protection against charged particles would become sources of additional radiation through interactions with the Doppler-shifted electromagnetic environment. The communication implications of this Doppler nightmare would make contact with the outside universe impossible during light-speed travel. Any radio signals transmitted from your spacecraft would be severely Doppler shifted depending on their direction. Signals sent forward would be blue shifted to gamma ray frequencies, making them undetectable by normal radio equipment and potentially dangerous to anyone attempting to receive them. Signals sent backward would be red shifted beyond radio wavelengths, effectively disappearing from detectable ranges. Similarly, receiving communications from the outside universe would become impossible due to these same Doppler effects. Radio signals from Earth or other spacecraft would be shifted to frequencies far outside the normal communication bands, requiring impossibly sophisticated receivers to detect and decode. The normal electromagnetic channels that allow spacecraft to communicate with ground control would be completely disrupted by relativistic Doppler effects. The navigation challenges created by this Doppler nightmare would be insurmountable. Normal stellar navigation relies on observing the positions and characteristics of stars and other celestial objects, but Doppler shifting would make most of these reference points invisible or unrecognizable. The forward stars would be hidden behind intense gamma radiation, while rear stars would be red-shifted into invisibility. The familiar electromagnetic signatures that identify specific stars and navigation beacons would be completely altered by frequency shifting. Even radar and LiDAR systems used for collision avoidance would become useless under these conditions. Radar waves transmitted ahead of your spacecraft would be blue shifted to gamma ray frequencies, while the return echoes would be further shifted by reflection from target objects. The normal radio frequencies used for radar would be completely absent from the electromagnetic environment, making it impossible to detect obstacles or measure distances using conventional techniques. The effects on electronic equipment would extend beyond simple radiation damage to include more subtle disruptions caused by the altered electromagnetic environment. Electronic circuits depend on specific frequency responses and electromagnetic characteristics that would be completely disrupted by Doppler shifting effects. Circuit elements designed to work with particular frequencies would find themselves operating in completely different electromagnetic environments, causing system failures even before direct radiation damage occurs. The quantum mechanical aspects of Doppler-shifted radiation would create additional problems for any matter attempting to exist in this environment. The altered photon energies would interact differently with atomic electron shells, potentially disrupting the quantum states that allow atoms and molecules to maintain their normal configurations. Chemical bonds might become unstable when subjected to electromagnetic radiation with frequencies far different from those present during their formation. The cumulative effect of this relativistic Doppler nightmare would be to transform the normally benign electromagnetic environment of space into a concentrated death beam that approaches your spacecraft from ahead while simultaneously erasing half of the detectable universe behind you. The familiar cosmos of stars and galaxies would be replaced by a tunnel of gamma radiation surrounded by expanding regions of electromagnetic darkness, creating an environment so hostile that no conceivable technology could provide protection. This Doppler nightmare reveals another layer of protection built into the universe's speed limit. Even if you could somehow solve the energy, collision, and structural problems of light speed travel, the electromagnetic environment itself would become so distorted and dangerous that survival would be impossible. The universe doesn't just prevent light speed travel through energy barriers. It ensures that such travel would be immediately lethal through multiple independent mechanisms that make the journey unsurvivable even for brief periods. As we prepare to explore how the fundamental laws of physics themselves break down at light speed, remember that this relativistic Doppler nightmare represents just one more way that nature protects itself from the catastrophic consequences of light speed travel by massive objects. The transformation of light itself into a weapon shows us that the universe's speed limit exists not just as a mathematical constraint, but as a necessary barrier that preserves the possibility of existence in a cosmos filled with electromagnetic radiation. As we reach the climax of our impossible light speed journey, we encounter the most profound and disturbing consequence of all: the complete breakdown of the physical laws that govern reality itself. Everything we've explored so far, from infinite time dilation to catastrophic collisions, represents extreme applications of known physics pushed to their mathematical limits. But at light speed, something far more fundamental occurs. The very equations that describe how the universe works begin producing results that have no meaning, creating mathematical infinities and logical contradictions that signal the collapse of our understanding of reality. This isn't just about physics behaving strangely. This is about physics ceasing to function entirely, leaving us in a realm where the basic principles that make existence possible no longer apply. The mathematical foundation of this breakdown lies in the Lorentz transformations, the elegant equations that Einstein derived to describe how space and time change with velocity. These transformations work perfectly at all velocities less than light speed, accurately predicting everything from GPS satellite corrections to particle accelerator results. But when velocity equals the speed of light, these same equations produce mathematical infinities and divisions by zero that have no physical interpretation. The Lorentz factor, which appears in all relativistic calculations, becomes infinite when velocity equals light speed, transforming every physical quantity it touches into mathematical meaninglessness. consider what happens to the concept of mass at light speed. As we've discussed, relativistic mass increases with velocity according to the equation Em equals m0, divided by the square root of 1 minus velocity squared divided by light speed squared. When velocity equals light speed, the denominator becomes 0, making the mass infinite. But infinity isn't just a very large number. It's a mathematical concept that represents the absence of any finite value. An infinite mass doesn't mean an extremely heavy object. It means the concept of mass itself has broken down and no longer has any meaningful definition. This mathematical breakdown extends to energy calculations through Einstein's mass-energy relationship. If mass becomes infinite at light speed, then the energy required to maintain that mass also becomes infinite through the equation E equals mc squared. But infinite energy isn't just more energy than exists in the universe. It's a meaningless concept that indicates our equations have stopped describing physical reality. The mathematics is telling us that we've pushed beyond the boundary where these relationships can provide meaningful answers about the nature of matter and energy. The breakdown becomes even more severe when we examine momentum, the fundamental quantity that describes motion in physics. Relativistic momentum equals mass times velocity divided by the Lorentz factor. But at light speed, this calculation involves multiplying infinity by light speed and then dividing by infinity again. This creates what mathematicians call an indeterminate form, where the result could be anything or nothing depending on how you approach the calculation. The concept of momentum, which is absolutely fundamental to understanding motion and collision, loses all meaning when applied to light speed travel by massive objects. Time itself ceases to function as a meaningful concept at light speed. We've explored how time dilation causes time to stop from the traveler's perspective, but the mathematical reality is more disturbing than simple temporal freezing. The proper time interval, which measures the passage of time in a moving reference frame, becomes 0 at light speed. This doesn't mean time passes very slowly. It means the mathematical framework we use to describe temporal progression produces results that have no interpretation within our understanding of reality. The spatial dimensions undergo equally severe mathematical breakdown at light speed. Length contraction reaches its extreme where distances become 0. But this creates fundamental problems for the mathematical description of space itself. How do you describe the location of an object that has 0 extent in one dimension? How do you calculate distances between points when the space separating them has contracted to nothing? The coordinate systems we use to describe position and motion break down when spatial dimensions lose their meaning. Perhaps most disturbing is what happens to the concept of reference frames themselves at light speed. Einstein's relativity is built on the principle that all reference frames moving at constant velocity are equally valid for describing physics. But light speed reference frames violate this fundamental principle because they produce mathematical impossibilities when you try to apply the standard transformations. You cannot consistently describe physics from a light speed reference frame because the mathematics that normally allows such descriptions breaks down completely. This breakdown of reference frames reveals a deeper problem with causality itself at light speed. Causality requires that causes precede their effects in time. But when time stops flowing, and spatial separations disappear, the very concepts of before and after, here and there, lose their meaning. Events that should be causally connected become mathematically indistinguishable from events that have no causal relationship. The logical structure that allows us to understand how events influence each other collapses into mathematical chaos. The quantum mechanical description of matter faces equally severe breakdown at light speed. Quantum field theory, which describes the behavior of particles and forces at the most fundamental level, relies on mathematical frameworks that assume finite energies and well-defined space-time coordinates. When energies become infinite and spatial coordinates lose meaning, the quantum field equations produce results that cannot be interpreted as describing any physical reality we can comprehend. The wave functions that describe particle behavior in quantum mechanics require finite normalization to maintain their probabilistic interpretation. But at light speed, where energies and momenta become infinite, these wave functions cannot be properly normalized, meaning they lose their ability to predict the probability of finding particles in specific states or locations. The mathematical tools we use to describe the fundamental constituents of matter simply stop working when applied to light speed conditions. Even more fundamentally, the concept of particles themselves becomes problematic at light speed. Particles are defined by properties like mass, charge, and spin. But when mass becomes infinite and spatial extent becomes zero, these defining characteristics lose their meaning. You cannot have a particle with infinite mass occupying zero volume, because such an object would create gravitational fields and energy densities that exceed any possible physical interpretation. The electromagnetic fields that permeate all of space would also experience mathematical breakdown in the presence of light-speed matter. Maxwell's equations, which govern electromagnetic phenomena with extraordinary precision under normal conditions, produce infinite results when applied to charges moving at light speed. The electric and magnetic fields around such charges would become infinitely strong, creating electromagnetic environments that cannot be described using our normal mathematical tools. This electromagnetic breakdown would cascade through all the forces that hold matter together. Chemical bonds depend on electromagnetic interactions between atoms, but these interactions become mathematically undefined when the charges involved are moving at light speed. The strong nuclear force that binds protons and neutrons together in atomic nuclei relies on field equations that produce meaningless results when applied to light-speed matter. Even gravity, described by Einstein's general relativity, encounters severe mathematical problems when dealing with objects of infinite mass and energy. The thermodynamic properties of matter would also face complete breakdown at light speed. Temperature, pressure, entropy, and other thermal quantities depend on statistical descriptions of molecular motion that assume finite energies and well-defined particle positions. When energies become infinite and positions become undefined, the entire mathematical framework of thermodynamics collapses. You cannot assign a temperature to matter that has infinite kinetic energy, nor can you calculate pressure when particles occupy zero volume. The conservation laws that form the foundation of physics would face unprecedented challenges at light speed. Conservation of energy requires that the total energy in a system remain constant. But how do you apply this principle when individual components have infinite energy? Conservation of momentum becomes meaningless when momentum calculations produce indeterminate mathematical forms. Even conservation of electric charge becomes problematic when charges are moving at velocities that make their electromagnetic fields mathematically undefined. Information theory and computation would also break down in light speed conditions. The processing of information requires temporal sequences where one computational state leads to another over time. But when time stops flowing, the very concept of computation becomes impossible. Digital systems that depend on precise timing relationships would find themselves in a mathematical realm where the concept of sequential operations has no meaning. The measurement process itself, which is fundamental to all experimental physics, would become impossible at light speed. Measurement requires the interaction between measuring instruments and the phenomena being measured, but such interactions involve forces and energy transfers that cannot be calculated when the objects involved have infinite mass and energy. The very act of observation, which is essential to the scientific method, would become mathematically undefined. Even the mathematical tools we use to describe physics would face internal contradictions at light speed. Calculus, which underlies virtually all physical equations, relies on concepts like limits and derivatives that become problematic when dealing with infinite quantities. You cannot take the derivative of an infinite function, nor can you integrate over regions where the integrand becomes infinite. The mathematical language we use to express physical laws simply lacks the vocabulary to describe light speed conditions meaningfully. The breakdown extends to the logical structure of physics itself. Science depends on the principle that physical laws should be consistent and predictable. But light speed conditions create scenarios where the same physical situation can be described by contradictory mathematical results depending on how you approach the calculation. This logical inconsistency undermines the entire framework that allows physics to make reliable predictions about natural phenomena. Perhaps most profoundly, the breakdown of physics at light speed reveals the deep connection between mathematical consistency and physical reality. The universe appears to be constructed in such a way that the mathematical tools we use to understand it remain internally consistent and logically coherent. When we push these tools beyond their domain of validity by attempting to describe light speed travel by massive objects, they break down not because of limitations in our mathematics, but because we've entered a realm that transcends the logical structure upon which reality itself is built. This physics breakdown also explains why the universe's speed limit exists as more than just an energy constraint. The mathematical foundations of reality itself require that massive objects cannot reach light speed, not just because of practical limitations like infinite energy requirements, but because such motion would shatter the logical consistency that allows physical laws to describe a coherent universe. The speed limit protects not just individual objects from destruction, but protects the mathematical structure that makes existence itself possible. The beautiful and terrifying truth revealed by this breakdown is that light speed represents more than a velocity limit. It represents the boundary between the possible and impossible, between mathematical meaning and mathematical chaos, between a universe governed by comprehensible laws and a realm where the very concept of law loses its meaning. Beyond this boundary lies not just extreme physics, but the absence of physics entirely, a mathematical void where the tools we use to understand reality cease to function, and where existence itself becomes impossible to define. As we prepare to conclude our impossible journey and explore the beautiful impossibility of what we've attempted, remember that this breakdown of physics represents the universe's ultimate protection against the catastrophic consequences of light speed travel. The cosmos doesn't just prevent such motion through energy barriers or collision dangers. It ensures that the mathematical structure of reality itself would collapse if such motion were possible, preserving the logical foundation upon which all existence depends. As we reach the end of our impossible journey through the realm of light speed travel, we find ourselves confronting one of the most profound and beautiful truths about our universe, that its ultimate speed limit exists not as a cruel restriction, but as an elegant protection that preserves the very possibility of existence itself. What began as a simple question about traveling at light speed has revealed layer upon layer of interconnected safeguards that the cosmos has woven into the fabric of reality, each one more sophisticated and necessary than the last. The universe, in its infinite wisdom, has constructed a barrier that protects not just us from the dangers of light speed travel, but protects reality itself from the mathematical and physical chaos that such travel would unleash. Throughout our exploration, we've discovered that the impossibility of light speed travel operates on multiple levels simultaneously. The energy requirements that approach infinity as velocity approaches light speed represent just the first line of defense. Even if we could somehow overcome this fundamental barrier through exotic physics or advanced technology, we would immediately encounter the temporal nightmare of infinite time dilation, where no time passes for the traveler, while infinite time elapses in the outside universe. This temporal freeze would make the journey meaningless from a human perspective, transforming travel into a form of temporal exile where the traveler exists outside the normal flow of time that makes experience possible. The spatial consequences prove equally devastating, with length contraction reaching its extreme limit and compressing all distances in the direction of travel to zero. This spatial collapse doesn't just affect measurements. It fundamentally alters the three-dimensional structure of space that makes normal physics possible. When the geometry of space breaks down through extreme contraction, the mathematical relationships that govern everything, from atomic bonds to gravitational attraction, lose their foundation, creating a universe where the basic rules of existence no longer apply. Our examination of the photon experience revealed that light speed existence transcends normal categories of matter and energy, placing travelers in a realm where time doesn't pass, distance doesn't exist, and individual identity merges with the fundamental forces of nature. This photon-like existence, while mathematically fascinating, represents a form of being so alien to human consciousness that it challenges our basic understanding of what it means to exist as a conscious entity moving through space and time. The collision catastrophe showed us that light speed travel would transform even the most innocent particles of matter into weapons of unimaginable destructive power. Every hydrogen atom floating in space, every grain of cosmic dust, every photon of background radiation would become a source of infinite energy release, making survival impossible even for the briefest moments. The universe filled with matter that normally poses no threat to travelers becomes a hostile environment where every encounter results in explosions that dwarf the most powerful nuclear weapons ever conceived. The relativistic Doppler nightmare revealed how light itself would become weaponized during light speed travel, with electromagnetic radiation from ahead being blue shifted into lethal gamma rays, while radiation from behind would be red shifted into invisibility. This transformation would create a tunnel of death and darkness where navigation becomes impossible and survival is prevented by the very light that normally illuminates our path through the cosmos. Most profoundly, we discovered that the mathematical foundations of physics itself break down at light speed, producing infinities and logical contradictions that signal the complete collapse of our ability to describe reality using the tools of science and mathematics. This breakdown reveals that the speed of light represents more than just a velocity limit. It marks the boundary between the mathematically possible and impossible, between a universe governed by comprehensible laws and a realm where the concept of law itself loses meaning. But perhaps the most beautiful aspect of this exploration is the realization that these multiple barriers work together to create a universe that is both incredibly dynamic and fundamentally stable. The same speed limit that prevents catastrophic light speed collisions also ensures that causality flows in a consistent direction, that time maintains its meaningful progression, and that the forces holding matter together can operate reliably across cosmic distances. Without this ultimate speed limit, stars couldn't maintain stable fusion reactions, planets couldn't maintain stable orbits, and the delicate chemical processes that make life possible couldn't occur in predictable ways. The cosmic speed limit also preserves the possibility of observation and measurement that makes science itself possible. If objects could exceed light speed, they could theoretically travel backward in time, creating causality paradoxes that would make it impossible to establish consistent cause and effect relationships. The scientific method depends on our ability to observe phenomena, form hypotheses, and test predictions, but such activities would become meaningless in a universe where effects could precede their causes and where the logical structure of time could be violated at will. This speed limit reveals something profound about the relationship between limitation and possibility. Far from being a restriction that prevents us from exploring the universe, the light speed barrier actually makes exploration meaningful by ensuring that the universe remains a coherent, stable place where exploration can occur. The same physical laws that prevent us from traveling at light speed are the ones that make stars shine consistently for billions of years, allow planets to maintain stable environments where life can evolve, and ensure that the electromagnetic radiation we use to study distant galaxies carries reliable information about their properties. The beautiful impossibility of light speed travel also highlights the incredible achievement represented by near light speed travel, which remains theoretically possible even if practically challenging. Traveling at 90% of light speed would produce dramatic time dilation and length contraction effects while remaining within the bounds of physical law. Such velocities would make interstellar travel feasible within human lifespans from the traveler's perspective, allowing us to explore distant star systems while remaining connected to the logical structure of space-time that makes physics comprehensible. The universe's wisdom in setting this speed limit becomes even more apparent when we consider the alternative scenarios we've explored. If light speed travel were possible, the cosmos would be filled with objects carrying infinite kinetic energy, colliding with infinite destructive power, and creating electromagnetic environments so hostile that stable matter couldn't exist. The familiar stars and planets that populate our universe would be impossible in such a reality, replaced by a chaotic realm where mathematical infinities make consistent physical behavior impossible. Instead, we inhabit a universe where the speed of light serves as both a cosmic speed limit and a universal constant that ensures the consistency of physical laws across all of space and time. This speed appears in equations governing everything from electromagnetic radiation to quantum mechanics to general relativity, serving as a fundamental parameter that determines how reality itself operates. The impossibility of exceeding this speed isn't a bug in the cosmic operating system. It's a feature that makes the system stable and comprehensible. The exploration of light speed travel also reveals the remarkable predictive power of mathematical physics. Einstein's equations, developed over a century ago, accurately predicted all of the extreme effects we've discussed, from time dilation and length contraction to mass energy relationships and relativistic Doppler shifts. The mathematical elegance of these predictions and their experimental confirmation in particle accelerators and astronomical observations demonstrates the deep connection between mathematical beauty and physical truth. As we conclude our journey into the impossible, we're left with a profound appreciation for the elegant complexity of the universe we actually inhabit. The cosmos has constructed multiple layers of protection against light speed travel, each one revealing new aspects of how space, time, matter, and energy interact to create a stable reality where consciousness can exist, stars can shine, planets can form, and life can evolve. The ultimate speed limit isn't a barrier that confines us. It's a foundation that makes our existence possible. Here on the lazy cosmos, we've taken this impossible journey together to discover that some of the most profound truths about our universe emerge when we explore the boundaries of the possible. The speed of light stands as testament to the remarkable fact that reality itself has built-in protections that preserve the mathematical and physical consistency that makes existence meaningful. Every time you see light from a distant star, remember that those photons have traveled to you at the universe's ultimate speed, carrying information across vast distances while respecting the cosmic speed limit that makes such stable, reliable communication possible. The beautiful impossibility of light speed travel reminds us that the universe is far more elegant and sophisticated than our everyday experience suggests. The same physical laws that make a simple flashlight work are intimately connected to the deepest principles governing black holes, quantum mechanics, and the expansion of the cosmos itself. By understanding why we cannot travel at light speed, we've gained insight into why the universe can exist as the magnificent, complex, yet comprehensible reality that surrounds us. So the next time you wonder about the limits the universe places on our exploration and discovery, remember that these limits aren't restrictions. They're the very foundations that make exploration and discovery possible in the first place. The cosmic speed limit that prevents light speed travel is the same principle that ensures stars will continue shining, planets will continue orbiting, and curious minds will continue wondering about the beautiful mysteries that fill our amazing universe. Thank you for joining me on this impossible journey through the realm of light speed travel. If you enjoyed exploring these cosmic mysteries, make sure to subscribe to the Lazy Cosmos for more adventures into the most fascinating aspects of our universe. Leave a comment telling me what impossible journey you'd like to explore next. And remember, sometimes the most beautiful truths about reality emerge when we push the boundaries of the possible and discover the elegant reasons why some boundaries exist. Until next time, keep looking up and wondering about the magnificent cosmos that surrounds us all.